Myself Naina HK. Our group members is Neha I, Manasa N, MS Salina Banu. Problem statement is topper identification system. Contents: introduction, objectives, design and planning, sources code, HTML and CSS, output, conclusion. Problem statement is: in many school and college, evaluating and managing the student academic perform is done manually or with basic tools which make it time consuming, error and inefficient. Teachers struggle with. Identify the topper performing student in each section. For example, A, B, C. Calculating the CGPA from row marks manually. Filtering student based on the specific CGPA range and academic analysis. Tracking the student for PBL for project based learning project. Creating the graphical summarizing and structured report for academic review. This manual process lack automation and visualization and integration, marketing unsuitable for real performing tracking. Objective: identify the academic topper in each section. For example, A, B, C based on their CGPA calculated for marks. Allow teachers to search and filter student within a specific CGPA range, for example 8 to 9, to provide user-friendly GUI using Tinker for interaction without needing write code. Display the graphical visualization for student CGPA distribution using the Matplotlib. Generate and export report to Excel using the Open PyXL for academic administrative or academic use. Track PBL project based learn project status for each student.
Start. The goal is to create a user-friendly topper identification system that maintains students' academic report section-wise ABC, identifies toppers based on CGPA, allows searching students in a CGPA range, presenting data via GI using Tinker. It generates the Excel reports using OpenPyXL. Provides visual representation of CGPA using Matplotlib, which is a Python library used for representing the graphs. This project helps automate academic performance tracking and integrates data analysis, GUI, and file handling.
Requirements. Software requirements are Tinker for a graph user interface, OpenPyXL for Excel handling, Matplotlib for graphs, TreeView for tables. Hardware requirements are basic laptop or desktop, minimum 4 GB RAM, Windows or Linux or Mac OS. Input requirements are of section A, B, C Excel files, columns, roll number, name, mark, CGPA, section PBL status. Output requirements are topper details, SGPA range filter, SGPA distribution graph, result in the table format. Methodology. Data design. Each student has student ID, name, section, marks, CGPA, PBL status. CGPA calculation. Python, copy code, def marks to calculate CGPA marks, written around marks 10, 1. Graph user interface. Tinker for drop down to select section A, B, C, button to identify topper, input to search by CGPA range, display area, example to text or tree view to show results. Building graph user interface. We use Tinker to create drop down to select section A, B, C, button to find topper of selected section, input box to enter SGPA and a button to filter students, buttons to show SGPA range graph, table to show result and a frame for graph. Loading and reading data. When the user selects a section like A, the system loads the corresponding Excel file like section A.xlxx, read students record read student record using OpenPyXL, stores them in a list of dictionaries for easy processing. Topper identification. On clicking identify topper, the program compares SGPA of all students, finds the one with the highest SGPA, displays the topper's full data in a table. SGPA range filtering. When a SGPA is entered like 8.0, the system filters all the students with SGPA between 0.9 and 8.0 and 8.9, shows matching students in a table. Graph generation. When the user clicks show graph, the system groups the students into a CGPA ranges from 6 to 10. Counts how many students fall in each range. Draws a line graph using matplotlib to visualize the data. Testing and finalizing. After building the system, we tested all section data loading, CGPA calculations, graph correctness, graph user interface functionality like buttons, inputs, and layout.
Designing
Designing.
front-end graphical user interface built using Tkinter. Section like drop-down input boxes and buttons. Previews tables to show result. Graph frames to display SGPA graph. And backend, we use read Excel data using Open PyXL. Filter and sort and analyze the SGPA and generates the topper information and graphs. System flow. In this code, we use the system flow like user open graphical user interface. For the graphics, select options like A, B, C section. System load Excel data. User can find the topper like search SGPA range, view SGPA graph, result show in table or graph, system alert if input is valid. Testing. In testing, functionality testing like test all buttons like topper, filter, and graph. The check different SGPA value and sections. Data testing like used sample Excel files with valid and invalid data. Verified SGP calculations and topper output. UI means user interface like searching, sorting, testing. Ensure all weights display properly, tested and responsive and error handling.
Code. First, we have imported Tinker as TK. This Tinker we have used for because we are connecting OpenPyXL and all. Next, OpenPyXL because we have inserted Excel sheets. Matplotlib for graphs. And first we have inserted 3 Excel sheets, section A dot section B, section C as Excel sheets, and then there are 2 list current data and headers. This is the function called load data function. Here it is this thing we have used for selecting the section. Next, according to the row, it is gonna select the section, and the next is for clearing the tree view, and the next graph is for giving the graph, and the next identify topper function is used to identify the topper. The code is related to that. Next, maximum, it will count the maximum toppers. Float, we have included float because of the decimal points we have used in the marks, and then it will also give the results. Next function, define filter by SGPA. The SGPA I have entered in the Excel sheets. All the SGPA are filtered. According to that, we'll be getting the result. If not, we'll be getting a warning. Please select a section first. Then this if will not enter the SGPA also, will get enter SGPA value. Next one is next function is for if not like the if I enter a section which is not matching with any Excel sheets which I have inserted, it will also show error for that. Next is for define column in. For column in headers, there is a for loop. Next function is define show graph. This if I press the show graph button, it will show the graph of that section according to the marks. Next, I have used the if else if statement. It will check the SGPA. If it is below that, if it is below 9.0 and greater than 8 point, it will count and give the number of students who has scored 8.0, greater than 8.0 and less than 9.0. And the next is plot, set title, set text label. All these are for graphs because we have used matplotlib. It will show for the graph, and the graph which we used is line plot. And the next one is this all code is for graph, color, grid and all, and graph frames. Next for the result, this is our code. As you can see, this is where we'll select the section and enter SGPA. If I select the section and select the topper, then I'll get topper. And if I enter the SGPA and I'll tell find students, the students who scored from 8.0 to 8.99, all the students are displayed. If I press show graph, I'll get the graph of that particular section. Now I'm gonna show my code. This is the Python code. This is the whole Python code, and this is my file export structure, which has section A, section B, section C, and topper app.py, in which my Python code is there. Our Python code is there. Now I'll run this in my open in integrated terminal. Then I'll be pressing Python. First we have to select the section. A section I am selecting. Now we have to identify the topper. Chirag Malhotra is the topper of the section, has scored highest 8.82 SGPA, and all each marks he has scored in each subject. Now I will be entering the SGPA. Find students. If I press the find students button, the students who have scored from 8.0 to 8.99, those students list will be displayed. If I'll say show graph, it will show the graph of the section A, because no one has scored the SGPA more than 9, so the graph has been decreased totally. This is our project. Thank you. Conclusion. Automated topper identification. The developed application successfully automates the identification of top performing students across multiple sections, reducing manual errors and saving teachers' time. Dynamic SGPA filtering for analysis. With the SGPA filter feature, the tool enables the teacher to quickly retrieve and analyze student performance within specific SGPA ranges. Interactive visualization. The integrated line graph allows for clear visual representation of SGPA distribution. It enhances the understanding of performance in each section. User-friendly interface using Tinker. The application provides an intuitive GUI-based interface where teachers can operate without needing any coding or Excel expertise. Address manual process challenges. By automating data loading, filtering, visualization, and topper identification, tool effectively addresses key issues mentioned in the problem statement, making the process more efficient and accurate and real-time. Thank you.